Hey everybody, it's Miss Glad. Hope you are having a good Thursday. We are going to continue with our lesson, starting with pigs and chickens. We're going to do some level 2 elimination and some work time. So let's go ahead and get started. So one of the toughest things we always know are word problems. And so what I wanted to do today is I wanted to set up a word problem, looking at a couple of different things, working our way through, and then using elimination. And it's a good little kind of hint as to what our level 2 eliminations are going to look like. So we have some pigs and chickens. Look at that cute little piggy. There's 13 animals in the barn, and some are chickens and some are pigs. Altogether, there's 40 legs. How many of each animal are there? Now, we could guess and check our way through this. Here's what we know. We know that there are 13 animals total. We're going to assume that all the pigs have one head and all the chickens have one head. So there's a total of 13 animals. So we need an equation that has to do with the number of animals. Okay. And so that's going to be my first one here. And I'm going to use C for chicken and P for pigs. So I've got the number of chickens plus the number of pigs has to equal 13. And again, we could guess and check our way through that. But the second part that we have to pay attention to is the number of legs in total. And here's what we know. We know that piggies have 4 legs and chickens have 2. So my second equation that I'm going to create has to do with the number of total legs equaling 40. So it's going to look like this. Top equation is my number of total animals. The second equation is the number of legs each of them have. So my system, it's got to work together. And ultimately, our goal is to figure out the number of chickens and the number of pigs. So I'm going to give myself a little bit of workspace here. And here's what I'm going to do. Okay, first of all, you might remember that I've missed my fancy bracket. Now, this is not on your page 9 notes. This is just in addition to, and just something that we're going to kind of work through. So yesterday, what we learned is we can set up using elimination where we vertically add the variables. And as I'm looking at this equation right here, I'm noticing that my C's don't eliminate and my P's don't eliminate. So that's kind of a problem for elimination. However, substitution isn't going to work great because notice that none of my variables are alone. I could use the Dezo's graphing calculator, but we're going to pull through here and we're going to stick with elimination. So to do that, what we're going to do is I have to use multiplication to force one of these equations to cancel out or one of these variables. And so what I'm going to do is if I'm looking at this, I've got, remember this is like a 1C and a 2C. For my P's, I've got a 1P and a 4P. And so nothing naturally cancels out, but what I can do is I can use multiplication to make the number of chickens cancel or make the number of pigs cancel. To do that, I'm going to force multiplication, and I'm going to force multiplication on this equation right here. And I can do that so long as I multiply every term by whatever number I want to grow it by. And so if I want to make the C's cancel, if I've got a 2C here, remember that the other number to cancel out would be a negative 2C because they've got to be pairs of opposites. Or if I wanted to make the number of pigs cancel, I would need if there's a 4P here, I would need this to be a negative 4P. So I can choose either one. It does not matter. I think I'm just going to make the number of chickens cancel because it's an easier number to multiply. So what I'm going to do is I'm going to take all of these times a negative 2. So times a negative 2, times a negative 2, times a negative 2. It's like the distributive property. And I'm going to rewrite this equation right below. So here I've got negative 2C minus 2P is equal to a negative 2 times 13 is negative 26. So notice that I've created an equivalent equation by multiplying everything by negative 2. Now, the good news about this is our C's eliminate. And now I can go ahead and combine the number of P's, which gets me down to 2P. And here I've got 40 minus 26, which is 14. Divide by 2, I get the number of pigs to be 7. So right over here, I'm going to say the number of pigs is 7 because I have just found that out, P equals 7. And once I've got the number of pigs, I can go back into my original equation. Actually, I could use any, but I kind of like this top equation because it's very simple. And so if the number of pigs is 7, so right here, I think I'll use this blue, actually black. Right here, if the number of pigs is a 7, I know that the number of chickens plus 7 has to equal 13. So what number plus 7 gives me 13? It's got to be a 6. And so here, notice that I did not write that as an XY coordinate point simply because we have labels. We have chickens and pigs. And I could put the 6 in for the C, I could put the 7 in for the P to double check that the number of legs work out, but they do. So that is an example of what we're going to do today. We've got to force some multiplication to make our equations cancel. So at this time, your yellow notes page should be open, and it is open to page 9. Guest teacher, if you need to pause for a moment to make sure all students have page 9 open, we are going to use these 3 problems to get us through to set up and solve. So here, you might notice that these 3 equations look a little bit different. And just by looking at them, this first one, I noticed that the x's do not cancel naturally, and neither do the y's. And so right up here, we are going to have to use multiplication to help eliminate these, to use elimination. And so if I'm looking at my x's, I see a 2x and a 3x. They are not opposites. They're not going to cancel. But if I look at the y's, one thing that I like about the y's is I've got a -1 and a positive 2y. So what I can do is I can make the y's cancel pretty easy by turning this -2 or -1y into a -2, because a positive 2y and a -2y will cancel. So I am going to choose this top equation. And to turn a -1 into a -2, I simply have to multiply everything on the top by a 2. Times 2, times 2, times 2. So I'm going to write my new equation right down here in the bottom. It becomes a 4x minus 2y, which is now equal to 2 times 3, 6. Now I'm going to set up my equation and I can combine my variables. So if I combine my variables here, I can put my 3x and my 4x together. That's going to give me a nice 7x. And my 2's eliminate, a positive -2y eliminates, all of that equals 14. Now, this is easy to figure out. Divide by 7, divide by 7. I have my x equals 2. So since I don't have any labels, I am going to use my xy. Oops, I better get rid of that there. It's not going to let me. So I'm going to change this. My x variable is a 2. So the only thing left that I have to do now is figure out my y. So I'm going to go back and I can use any of these equations. And when I use those equations, I need to, wherever I have my x, I'm going to put a 2 in. And so I can use this one to put a 2 in. So it's going to be a times 2. Or I could use this one. It's going to be a times 2. Either one works. Okay, so you pick one. You've heard me say that I kind of shy away from subtraction signs or negatives just because it's an extra step. So I think I'm going to choose this equation to plug my 2 for x in. So it's going to look like this. 3 times 2 plus 2y equals 8. Now, I've got 6 plus 2y. Writing with a mouse is annoying. Minus 6, and so when I balance this off, I get 2y equals 2. Oh, looky here. Divide by 2, y equals 1. So I have my solution right here, and I was able to do that by forcing multiplication. Let's look at example 2. Example 2, if I'm looking at my x's here, they don't quite cancel. Same thing with my y's. I've got a -7 and a +2. So that one would take a lot of work. I'd have to change both of my y's to cancel. So I'm going to choose my x's simply because if I've got a 6x, I can force multiplication on the -3 to become a -6. So I'm going to take this top equation and I'm going to multiply everything times 2. Okay, so I already like that there's a positive and a negative here, but by me multiplying times 2 times 2 times 2, I'm going to flop that to -6x. 2 times a -7 gives me -14y, and that is equal to 2 times 2 is 4. Now that I've completely rewritten that top equation by multiplying everything by 2, I can go ahead and I can combine my variables. So I notice that my 6's eliminate. Yes, that's what I wanted. And so a 2y minus 14y gives me -12y. And that is equal to 8 plus 4 is 12. Divide by -12 on the left. Divide by -12 on the right. Pretty quickly, we get y equals a -1. So right here in my XY format, I've got a -1. Now that I've got my -1 for y, I've got to go through and choose one of my other equations to insert my -1 for y. Again, you can choose whatever equation you wish. I notice the top one has 2 negatives there, and it's kind of nice not to have to worry about that. And so I think I'm going to choose my second equation to plug my -1 in for y. So here we go. I've got 6x plus 2. Now instead of the y, I'm going to put a -1 in. There it is. I've plugged in my -1 for y. All of that equals 8. So we've got to get the x alone. -2, this turns into a -2, so it's 6x plus a -2 equals 8. So I need to add 2 to the left, add 2 to the right. And as I go through here, that's my -1. I get 6x equals, oh gosh, that doesn't seem a -1. A -1. I'm gonna pause. So as I keep going here, yes, my x's cancel. I paused because check this out. 6x equals 10. Divide by 6, divide by 6. Now I just went through and checked the other one as well. And so my x equals 10/6. This is the first time we've got a fraction, which is okay. We're just not used to getting them. And so I'm going to reduce my 10/6 to be 5/3. So it's 10/6, which is 5/3. Whew, first fraction, there it is. Definitely ups the level of rigor just a little bit. All right, last one. I am looking and I see that my x's do not cancel. My y's do not cancel. But I can make either one cancel, forcing multiplication. What I do like about the y's is that they're already positive and negative. So I think it would be easiest to make the y's cancel. Now we could do the same thing with the x's. I could make that a -5, but I'm going to keep those y's. And so what I'm going to do is I'm going to multiply everything here times a 3. Times a 3, times a 3, times a 3. So that's going to give me 3x minus 3y. Ooh, I like it. And 3 times -3 is -9. Now, when I do my canceling here, I see that my y's eliminate, and that's what I was hoping for. So we end up with 8x equals a -8. So here, divide by 8, divide by 8, I get my x to equal a -1. So recording my answer, -1 for x. Now that I have my x value, I can go back and I can choose one of my equations to use to find my y. It doesn't matter which one. Again, the top equation has a lot of negatives. So if you want to pick that, you can. I think I'm going to pick the second one. So right here where the x is, I'm going to plug a -1 in. So it's going to be 5 times -1 plus 3y. Let's see if we get a fraction again. We might. All of that is equal to 1. So -5 plus 3y equals 1. So I need to add 5 on the left. I need to add 5 on the right. My 5's cancel. And we get 3y equals 6. Oh, good. Divide by 3, divide by 3. Y equals 2. There is my solution for that last one. So for today, okay, we just finished level 2s, okay? Dig out your pink homework from yesterday. Yesterday, you worked problems 1 through 7, okay? And so today, you now have enough information to continue on. I want you to finish number 8, 9, 10, 11, 12. And you are going to see that to eliminate one of those variables, there's one that works out pretty easy. So right away, I'm looking at number 8, and I see that both of my x's are 3x. My y's don't cancel. But what we can do is we can actually make those x's cancel pretty easy simply by taking and making one of them a -3x. So to do that, I'm just going to pick this top equation and I'm going to multiply everything. To switch the sign, we just multiply everything times a -1. And so times -1 times -1 times -1. So I'm going to rewrite that equation as -3x minus 3y, yes, this is an x here, is equal to -19. Ooh, I like multiplying by -1. It basically just flips your signs. And so then we have made our 3x's eliminate. And, oh dear, I multiplied that wrong. This is not, I looked in the bottom one. So this is a -3x. This is a -4y. And so 6y minus 4y gives me a 2y. So we've got 2y equals 33 minus 19 is 14. There we go. Y equals 7. So you have your y value all ready to go. Y is a 7. And so to figure out your x, now you've got to pick one of those equations. You're going to put a 7 in, and you're going to figure out your y. So if you look at yours here, again, I'm looking at 9, -3y, -3y. That one's going to be easy to force multiplication on. Just pick one. Pick one, and I would multiply by -1. I kind of like getting rid of some of these negative signs. So maybe for number 9, you multiply everything times a -1. That way, every sign flips. So it turns into a 5x plus 3y, and this turns into a -30. So what we did is we took this equation, we flipped everything. So now you can see that a -3y and a +3y. Sometimes once you switch your equations, you might want to ignore this so that it doesn't get kind of lost in the shuffle, because here's your new problem, right? Combining your x's, combining your negative, positive y, those eliminate. So you've got a few problems to finish up. And tomorrow, that front side will be collected. Hey, have an awesome rest of your day, and I'll see you soon.